you got excuse. I can understand because you got to make up an excuse to not to submit your homework. And just like I say, the homework is very important. If you don't submit your homework, it's a serious fault in your learning. So you got to submit your homework. So I'll reevaluate how much effort you put on your homework as well. Of course, you might say, I don't understand the problem you ask in the homework. Yes, you probably don't understand for two things. Probably for one thing, you probably don't participate at all. So that's one thing. For the second thing is that you really participate, but you don't really understand. But the thing is, before you submit your homework, you almost have 3 or 4 days to ask me what's the homework about. If you don't really understand the question, please ask me before that. You can't just keep on delaying until the last minute and you told me, sir, I don't understand the question. It's unfair. It's unfair. It's I've been teaching you for 1 week, and in the last second, you told me I don't understand the question, the problem. It's unfair. It means that I'm just wasting my time. So take it seriously. Or I'll at least I told you I take seriously. So it's your responsibility, self-discipline. If you don't think it's important, fine. Then it's not important. If you think it's important, I want to pass this course. I don't want to learn again. And at least the language this teacher is speaking, I can understand. So I have a chance to learn more. And he sent me the textbook. I have a chance to pick up the book and to learn more as well. So if you stick to this and force yourself to learn a little bit, I don't think you have any problem. You can pass this course, no problem. But if you just wasting your time, and then you might wasting other people's time as well. So please take seriously. That's just my recommendation. Up to you, because I cannot see you. So it's completely up to you. Whether you want to participate, or you want to submit homework, you take seriously or not. I don't know. But I can easily judge from your performance. Trust me, I can easily judge from performance. Just to let you know. Okay. So we should supposed to have like 50 people. Now it's only like 20. So I don't know. It's physical class. You have some people absent from the school, from university as well, but not so many. So it seems like it's too many of you. Just don't take seriously. Anyway, we broadcast in time and on time as well. So if you lose the chance to learn, then like I don't know what to do. In the end, I just judge by your performance. Okay, that's just my opinion towards you guys. I don't know any of you because I haven't told you guys before. The other class I told them before, so I know all of them. So they know my character as well. So I don't have to explain anything to them. So they know what I'm going to do or what's the market and everything. But I don't know any of you. So it means that okay, I only judge by your performance, your homework, your participating, your essay, and from your everything. So that's basically so take seriously. Okay, so since last time the class monitor told me some of you don't submit homework because they don't understand the question. So the best way is I go back. And by the way, I think I have to every time I have to finish the class probably 5 or 10 minutes before, and then I can have give you some time to ask some questions. If you have some questions, you can ask some questions. Okay, I think it's a better idea rather than rushing through the whole class. I just give you some 10 minutes time for you to ask some question, and during the break, we don't have breaks too much, but during the break, you can also ask the some question. And even in class, when the class is going, you can ask me any question you like as well. Last time I told you I can call me whatever. So there are many ways to learn. Just don't postpone to the last minute and then told me I don't understand the question, then it's completely unacceptable. Even if you put in my shoe, you can accept your student like in this way. So take it seriously, or I don't know. Okay. So let's remind you some of the lecture we just going to. So the chapter one, we have to finish chapter one because chapter one is about the basic about the statistics, and I told you guys already. The reason is chapter one is very important. Is, as a surveyor, you have to tell people the meaning of your measurement. Otherwise, people don't know what's the meaning of your measurement. So the best way is to give people the statistic property of your data. Okay. So this is the one we mentioned last at least last 2 weeks. So you must have some familiarity of this stuff. So pretty much, let me remind you. Pretty much the reason we are doing this one is we want to get some value, because we don't know the true value. So we're gonna get some value based on some measurement. Suppose from A to B, I want to know the distance between A and B. And what am I gonna do? I need to measure the distance this one by different kind of instrument, by different kind of method. So once you measure, you have errors. So the best way is you write down we call the most probable value. Most probable value is your mean. Most probable. The mean means is most probability. Most probability that's going to happen. It's called most probable probability. Plus and minus your error. Normally, if you have a most probability based on mean, this is your standard error. Just like if you buy a package of chips, normally you have like the chips, the pack of the chip, like 20 grams plus minus 0.1 gram, and this one might be the standard error. It might be we call there are many ways. Your standard error that might be one, and another one might be absolute value. The error I call as over here. There's a error over residue. You can also call it relative. So there are many ways to explain. Another one is called relative error. So this is an absolute error, or absolute error. It's based on absolute value, and also another one based on percentage is called relative error. So far you still you at least have 3 ways. So we have to learn. I have to ask you guys write your either your essay or something in this form. Once you finish the measurement through your via your instrument, you have to write in this form. So this is your most probable value. If you have a 5 machine, you have like a mean 5 mean, and then you have to write down either this one or this one or this one. Based on what? Based on the approach you are using. If you are using statistic, you probably have this one or this one relative error, or you have absolute error. For example, like the scale, the tape you use. Suppose you are using tape. This is you are going to measure A to B, A to B. So you are using tape, and your tape is 10 meters, and the scale of your tape probably is like for example is 1 meters, 1 millimeters. So it means the scale, the precision is up to only 1 millimeters. So in this case, you have an absolute value that might be written 1 millimeters. 1 millimeter. It means there might be an error within 1 millimeter because the scale is not so precise. So there is still some errors. Or you can write into some we call relative based on the this one the scale of the tape, the whole length of the tape. If the whole length tape is let's say is 10 meters, and you have 1 millimeters over here. So 10 meters, 1 meter is times 10 raised to 3. meters, centimeters, and millimeters. And then you have 1 meters over here. This will be your relative errors. I put over here your relative errors. Okay. So there are many ways to write this one. But so far in this book seems like or other book as well. I check many books. It seems like they just separate them, just like write this one place and then write this one another one. They don't put them together. Indeed, you have to put them together. Otherwise, there is no point learning all this bit. From now on, if you do some measurement, you got to write in this way. You can't just write the MPV or you just based on one. Of course, you say I just do one measurement. Of course, it's inaccurate. If you just say, okay, I use my tape. If the tape tell me it's 30 meters, 30.2 meters, then it's 32 meters. But the only based on one observation is most of the time your client is not happy. They will ask you to measure it like 10 times or 20 times. Okay, so let's go into and by the way, I can I think the majority of you, I guess, because you don't talk to me, your problem, so I guess the majority of you probably have a problem in the problem is called weight, and that's the most important one. So that's the reason we spend some time on weight. But to fully understand the idea about weight, we have to come to a little bit of statistics. So now what I'm going to do is I want to I write down even a proof the some of the basic one. But I won't hold your hands one by one to go into all the proofs. But what I'm gonna do now is I want to send you guys the first page of the one I writing down everything. So just hold on for a couple seconds and I write, and then you can open this one and take a look. I send to your widget. I send to your group widget. So widget group you can see. Now probably you don't have to see. I just open this one. This is my handwriting. So it takes a lot of time to have this one. This paper. Okay. So you can. I probably can see it because it's on my screen because everyone can see my screen. So I think anyway, if you have any problem, just raise your problem soon. And today we are going to use your pen and your calculator to do some calculation as well. Okay, so look at this one. This is basic statistics. That's the name where the statistics come from. Every one of them is called statistic. And basic statistic is in another name is called random number. And there is a random variable. There is two property over there. Is a random and is a variable. So it means it's unknown. This one is unknown. But normally there you can know the distribution. For example, the most popular one probably is a normal distribution, exponential distribution, many different kind of distribution, uniform distribution, chi-square distribution, different kind of distribution. But in this course, you probably don't have to know so many distribution. Probably the one you have to know probably is a t distribution or normal distribution. You don't have to know. But for the basic one, we talking about weight, so we have to mention a little bit about this one. So this is your variance, your variable. So variable basically you can express like this way. You can express your variable like this way. Let me draw something over here. This is a basic. Basically, if you have some distribution, it might be it doesn't have to be normal distribution. It can be any distribution, and the probability in the accumulation probability is 1. So you have any. This is a variable. This is a variable, and in this scale is your probability. So this is your domain, the value of your domain. So every value in your domain, they have a corresponding probability, the chance it happen. What's the probability it happen? So, for example, if this value is 100, so we have a probability it happen over here. So this basically, this is a random variable, statistic. We call it a statistic. It's a random variable as well. So that's a basic idea. So for this every distribution or random variable, you can treat it as a distribution because it's not a number. Basically, it's just a function. It's a function. So that's the reason you can't pinpoint anything. You only can pinpoint them by probability. Many physical things they are described by distribution. They can't pinpoint. For example, the atom, the electrons, the way they behaves. They all behaves like probability distribution. You cannot pinpoint or predict the exact position of electron in the next second. No way. But you can predict. It's based on this probability. You can predict the next point is going. What's the probability for him to locate in the position 11? You can look. You have a chance. The probability. So it means in a position 11, you might have a chance to find out this high chance to find out the electron will be in the position of 11, something like this one. So X basically is your domain, and the chance that I happen to find out this one. And so every random variable basically you can treat just like distribution. It might be some weird distribution. Looks like very weird, it doesn't matter as long as your random number. It might be any kind of weird things there, but no matter how weird a distribution is, always have something called mean, and also there is something called variance. Something mean indicates the middle point of the. If you treat this one as a metal of a piece of metal or something, then mean pretty much is the center. We call the center of the mass. And the variance just to look at how wild it spreads, the data is spread. So and your distribution might be normally you look at it, then they are continuous, look like function continuous. It's because it's easier to do the calculation. But most of the time, you are facing more like this one. For example, you are casting the dice. You're casting the dice pretty much 1, 2, 3, 4, 5, 6. There is no 1.1 or something like that. So in this case, 1.1 probably you can treat like this one. It's the probability to appear as 0, and some 1 probably is this one. So 0 again. So this might be also by your distribution as well. And again, you have a mean and the variance. Okay, so mean and variance are the property of every distribution, no matter what kind of distribution it looks like. They always have a mean, and always probably is anyway in your code you can say it's always, but in some extreme case it's not always. But anyway, so let's claim I always have a mean and variance. So mean and variance become very important property for every distribution. So we must care about mean and distribution. So mean is your most probable value. Most probable, basic means your most probable, and variance pretty much. Of course, we call standard error, so it must this one a little bit different. You have to take the square root of this one as well, and also you have to consider whether it's sample or not. Anyway, but it's pretty much plus some standard error, pretty much like this one, and this is the typical form for a surveyor to present your work to your clients or to me as well. You have to write your essay or your everything. Even if we have an exam, you have to write them more like this one. You can't just write down the MPV because it's unfair. But again, you have to base on some assumption. In order to get this mean and this variance, you must base on some assumption. But normally the assumption is based on the normal distribution. In particular, you have dealing with and the one you pretty much face more is called the mean. this mean. So this mean slightly different from this one. Slightly different. This one itself by itself is a statistic. So before you do the casting, and from now on, if I write this one means it's a statistic. You don't know yet. But if I write this one, in order to classify the difference between this one and this one, and this one, if I write this one, just for my notation, my usage, for you to clarify the notation and the notion as well. So in this one, this means statistics. So this once I say is a statistic, it means it is a distribution, be like this one. But this one basically just means you do some sampling, and then you do a calculation based on this statistic. Based on this statistic, you get some real time. So this is a realization. So this will get a number. This is a number. This is a number. Okay, this is a number. You have to tell them difference. Otherwise, you're always confused. What's the difference? Looks like they are all the same. Always. This is a number, a real number. You can calculate this one based on a sample. So basically, this is a sample. But this one is not. This one is not a number. This one is a function. This one is a function. Of course, the shape of the function or something based on the combination of other random variables. So basically, this is a combination of other random variables. Suppose I have other random variable S1, Si from 1 to n. So it means I have n random variables. Each variable in my, for example, x1 is dice, or you can just say x1 is first one dice. You have 10 dice. Then the first one dice, second dice, third dice, and so on and so forth. I want to know the average. Of course, divided by 10. I want to know the average of the 10 dice. If you hold 10 dice in your hands all together and then throw it at once, what happened? What is the average value? That will be this one. And before you do the casting of the 10 dice, that this one is called statistics. You have some distribution. Based on the every one of them, probability of one of them. You have some distribution. So x1 have some distribution. X2, suppose x1 is a dice and x2 is a pack of your poker or something, and you have a different distribution. So this is x1. They are all random variables. You treat that. So far there are only two things you have to tell yourself. One is a function. So are you facing a function or you are facing a number? So it's easy to tell. If you are facing a function, then it's a random. We call this function called random variable because you don't know is the probability included. So it's called random variable. The best way you can do is just write out the behavior of the objects, random variable. But once it's realized or sampled or cast or dice cast, then it's a number. So it's very easy to tell. Some of you always confusing. Like how can I tell is a realization or is a statistic? Statistic is basically just a function, and the realization number. So there are only two of them. So it's easy to tell. So this one S1 is a distribution, kind of distribution. S2 is kind of distribution. X3 is kind of distribution. Okay, and so on and so forth. For example, you have a 10 distribution, different kind of distribution. Then you put them together into another function, by using this 10 function, and you generate. How to generate this function? You put them, plus them together, plus them together. Of course, based on their probability theory, you'll get the distribution of this one. Based on the 10 random variable. So this one itself is already also a function. It might be look like this way. Just a random plot. This one, just to let you know, this one also is a random variable. And why this one is so important? Because this one take every function into consideration. So this one the result much more moderate. For example, x1 could be the first person, because you are measuring. For example, you are measuring the point from A to B. You measure 1 point from 2 point from A to B, and then you assign 10 people to do this one for you. So the S1 before he do the all the observation or measurement, there is a probability look like this one because it's still unknown whether how much is he going to get from the distance of A to B. They all differ, although it might be differ a little bit, just be like by second or something, but they differ as well. So their distribution change before they do the observation. They have their distribution. It might be also be the machine. This machine might have some systematic problem. You always have the middle always over here, lies here. And this machine is another type of machine. Always the middle one always lies over here. And so is this one as well. So it may also represent different type of machine as well. So before you do the measurement of the distance from A to B, also before you do the measurement, use this machine. There is a probability over here because you don't know what's the value of this machine is going to get before you do the measurement. You don't know, but you know there is based on the type, the property of this machine. You already know the machine tends to have this kind of distribution. Even you haven't done the measurement yet, but in the specification of the machine itself, they'll give you some kind of like distribution of this kind of machine. This kind of machine tends to have the middle over here and so on and so forth. So different kind of machine, they have a different kind of like distribution as well. Although they change just a little bit, they won't be this far. Maybe just the shape or something a little bit different. So that's a basic idea about the random variable. Okay, so let's go back to the one I sent you guys. Okay. So this one pretty much I impress every basic stuff you need to know in your chapter 1, even chapter 2. But it's not like one individual chapter. We have to use all of them. So we are like that's normal. That's normal. We always keep accumulate different kind of bits put them together. Okay. So this one is a random variable. This one is a random variable. So you have we use E. E means expected, is expectation or expected value. E stands this one. So this random variable, you have expectation value. So basically, let's go back to this one. So every distribution, Y stands for every distribution. Y stands for this Y. This Y stands for every distribution. Just one distribution statistic, one distribution. And for every distribution, you can get the mean and its variance. Its mean and its variance. So basically, this it might unknown, but most time we assume it's known. Normally, assume this normal distribution, this chi-square distribution, the t distribution, and blah 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 f distribution. All kinds of assumption based on the property of your data. You might give it some assumption. So this one, and once you have an assumption over this y, you can get EY easily. Normally already theoretically, all these are theoretically stuff. You can once you because it's in a perfect world, like normal distribution, perfectly in only in ideal world. You have a normal distribution, so you can do the calculation. They calculate the mean of this normal distribution, or you get the mean of uniform distribution, different kind of Poisson distribution, different kind of distribution. Every distribution is just a statistic. Okay, so you can easily get the mean and the variance of this distribution, and that is called statistic. So pretty much every statistic or every unknown distribution, I just treat them all the same. Although it's a different name for the statistic, but I just treat them all the same. They are all called statistic, and you also distribution statistic basically is a distribution. So you can also get its mean and its variance from a distribution. Every all of them have a mean and distribution. Okay. Now comes to the problem. What's the problem? The problem is that we don't know the true one of this one, the true one of this one. So the basic even this one, this one, because you don't know the true one, the true of this one. So the best way you can do is just based on the guess, What I want to do is I want to show you this one. Previously, I was talking about this one, S1, S2. You assume you already know S1, distribution S2, S3. If you already assume you know these ones, then this you can easily get this one identical, not identical, exactly to the dot. No problem. You can get this one. No problem. But the problem is that you don't know S1, S2. So it means that they are in a black box. There is a distribution. Yes, assume there is one. But I don't know because it's covered by it's blindfolded. So it's covered in the black box. So I don't know this one. I don't know this one. I don't know this one. In this case, I know there is a distribution. There is a random variable over here. There is distribution. There is distribution over here. But the thing is that I don't know exactly what the distribution look like. In this case, how are you going to do we call the inference based on statistics? Yes, there is still one way. There is it's called use this one. This one is the mean of all the statistics. This is also is this one. This is the exactly this one. This is you use the average. You average out all the statistics. Of course, itself is also statistic. It's also statistic. So in this case, if you like, you can explain like this statistics have a random variable 1 is influenced by random variable 1, random variable 2. This is a special case, like is you take the mean, this special case. But normally you can write like this one. If they are influenced by different kind of random variable, you can write this one. So f itself is also random variable. You can say f is a y. F is a y. Today we will talk about this bit as well. So f you can say f the y value is also random variable. Why? Because y depends on x1 up to xn. But the thing is that s1 is a distribution. We don't know exactly how it look like. S2 is a distribution. So in this case, if you don't know the exact distribution, the shape, that distribution of s1 up to xn, how are you going to do the inference? You can calculate what I call mean, and this mean it independent of the s1 up to xn. As long as you take a mean, and then the n, if you take n large, this random variable, there is a weird property. It's not weird property. Indeed, is easy to imagine. This one tends to become the normal distribution. Normal distribution. Because of this property, because of this property, it saves a lot of time and the wild guess. So the best way you can do is I use the mean. I use the mean. Because in the end, if you it depends on one condition. N must be large, so you must consider take many random variable into consideration. Then in this case, this random variable, this one is also a random variable. You don't know. This one will tends to be a normal distribution. And since you don't know x1 up to xn, so you only know it's a normal distribution, but exactly the mean and the variance you don't know yet. So this mean and variance is unknown. This mean and variance is still unknown. But if you know s1 up to xn, if you know the exactly distribution of this one, you can easily get this mu and this sigma. Okay, so now that's the reason you always heard something like standard error of mean. Here we have something called standard error. When we also have a standard error of mean. Last time we talked about standard. We are talking about this one. We are talking about this one. So if you do some observation, you can trade S1 up to X10. You have 10%. S1, you have 10 data. This one is a control one distribution. This one is controlled by another distribution, and so on and so forth. And then they do the calculation. So basically, when you do the average, you average that. It basically you are assuming you are doing this one. Why do we care about the most probable value? It's because the most probable value normally is generated by x bar. X bar tend to have this kind of distribution when n is huge. In other sense, if you do the measurement, another measurement of one A to B, if you do a large measurement, for example, you do 1,000 times, A, B, do 1,000 times. This one will be very accurate. Okay, because most of the time you get you get a normal distribution very close to here. So if you use this number, if you measure 1,000 times and record all the value, and you will see the most happened time will be line just a normal distribution in this one, the high chance probability over here. You can get this value. So you can treat this value as your most probable value. This value as the most probable, and it's reliable. Why is it reliable? Because it's the most likely to happen in this case because it tends to be the normal distribution, and this point is have a higher probability. So if you take this point as your the distance between A and B, that's the most representative based on the theory of statistics. But on one condition, you got to measure them as many times as possible. Then it will become very accurate. This number tends to have a normal distribution, and they can tend to have this number will be very representative. Otherwise, if you just say I measure one times and I take this one time as this mean, it will be very inaccurate because you might get a number over here. You might, but if you measure 1,000 times or maybe 10,000 times, you'll get the value very, very close to here. Because after 1,000 or 10,000 times, the shape you get will pretty much like this shape. If you say I measure 1,000 times, you recall every 1,000 times. The first time, you get some number. The second time, you get some number. Okay, so based on this, I'm going to ask you now to do one plotting. And one diagram. So this is you measure one. For example, you measure let's say 20 times. You measure 20 times, and each time you have a value, right? Each time you have a value. You just recall a value. For example, this 10.1, 9.98, and so on and so forth. You have 10 times, and then we can do the plotting. You can do the plotting. You can record the plotting. So X is basically your observation over here. You have an observation. This is your measurement. 1, 2, 3. You have 20 observation over here. So you just record it. For example, like you record 1.1. 1.1. Out in among the 20 times, how many of them they are recorded as 1.1? So you record the times. So Y value is your times. How many times do you get 9.1? Or if 9.1 so is too small. For example, it's like a dice. With a dice, if you cast a dice 20 times, if you cast a dice 20 times, you can record number 1. What's the appearance? How many times of what side 1 being appear? So for example, you get like 4 times, and then you cast the dice. You record how many times, how many of them out of 20, how many of them the size of the dice, the 20 dice, they are 2. For example, you have your appears to be 2 times, and so on and so forth. You just recall all of them. 6 point. For example, you can get like 5 times appear. This one. You just recall all of that, and then you will get a plot. You get a plot. You get plot there. You get a plot. This one 10. So you get a plot. So based on this one, if you do all this, you also get a plot of this one. You can do the average. You can, for example, every time you have like how many? For example, just an example. For example, you have like let's say you have let's not to be complicated. Let's just make it easier. You have like 10 balls over 10 ball, the number of balls. So it's number 1, number 5. number 6. You have 3 balls in this bag. Another 3 balls, maybe 2 balls in this bag, right? And then as what's S bar. S bar basically you get one number S1. Before you get a one number, this number is a random number. This number is a random number because you don't know what's going to happen. So the distribution is one will be appear 1/3 of times. So the probability here is 1/3. 1/3. Because only 1, 2, 3. So the chance for 1 to appear is probability 1/3. The probability of 5 to appear is also 1/3, right? Probability of 6 to appear is also 1/3. So this is your distribution. This is your distribution of x1. Before you do the drawing, this is your distribution. Also, you have a distribution over here. So this is x1. Your random variable is this one. So when you has the distribution of x1 will be like this one. These are probability 1/3, 1/3 is one. And the other distribution x2 is over here. And they are independent. We'll call x2 and s2 independent. Why they are independent? Because they are when you draw the x1, you won't be influenced or influence x2, and the other one around as well. If you draw the x2, you won't influence or be being influenced by x1 because they are separated. The bag are separated. So in this case, you see when you have number 2, this domain 2, x2 domain is a 2. Your probability is half. So it's 1/2. 1/2 of the probability is number 2. Also, you have 10 is also 1/2. So in total is probability is 1. Is 1. So let me get rid of this. Use the point. See, this is our second distribution. S2 distribution. Now what I'm gonna do is I draw. Of course, for A and B, this case, A to B, this case, it won't look so different because it's completely different. Like 1, 5, 6, 2, 10, they're completely different. They'll be very similar. Like this bag and this bag are very similar. Although they are independent, but they are very similar because no matter who is doing this measurement, they'll be very, very close to each other. They won't be so different. I just make it a bit okay. So in this case, I want to calculate the average of bar. This S bar. S bar is also a random variable. Is 2 x1 plus x2. 2 s1 plus s2. So in this case, you see, before you do the drawing, of course you can draw one over here. You can get a S bar directly. But before you do the drawing, this here is a statistics. You don't know yet what happened to this one. So you can also do the plotting of this one. So this one, for example, how am I going to construct the X bar, the distribution of this one? Easy. Now we have let me do the table over here. I'll finish this one and then I will give you one exercise. You will go to this one because if you hear what I say, it's easier, but you have no impression. Once you finish the course, you forget everything. So I'll finish this one, then I'll give you a little bit of time to do exactly the same procedure to calculate the mean. How do you get the distribution of this mean? Then you have a very concrete idea about everything. Otherwise, it's a bit abstract for you guys. Okay, so we'll focus on using pen calculator. This kind of thing to help you understand everything. Everything. Okay. Initially, this kind of course belong to statistics and probability, and it doesn't matter because even it take a lot of people, even they take this kind of course, they still don't know what does that mean. They know by book, they know they pass the exam, they pass everything. But if you look deeply, what does that mean? They have no idea. So this is a good chance for you to do some revision because you are going to face very practical. As a surveyor, you are going to face some very practical data very soon because you will be graduate from the university very soon. So you're going to have take some job or something, surveying. So these are all very practical one, very close to the real life. Anyway, so how am I going to know what's this S bar this one look like? First of all, you have to calculate probability. It's called joint probability first. So you have a joint probability table. Joint probability table over here. Joint probability. I'm supposed to write a straight line. Joint probability. Okay, and on this joint probability, this is your x1 random variable. This is your x2 random variable. Okay. For the x1, you have 156. This is your domain, the value of your domain, 156. Okay. For the x2, you have two values, 2 and 10. It doesn't have to value to be number. It can be anything. It can be anything. You can have anyway. It can be dice on it. Dice. How many points of dice or something. It doesn't have to be number. It can be like black or white or something. Anyway, but you here. Let me get rid of it. Here you have a probability. We call it joint probability. Let me write in this way. Joint probability. Joint probability. Okay. So when x1 appear to be 1, x2 appears to be 2. What's the joint probability? When you appear, basically I just multiplication of 1/3 times 1/2. So it's 1/6. 1/6. This joint probability because if they are independent. If they are not independent, then you can't do the multiplication. Basically do the multiplication because they are independent. So the chance for 1 to appear is 1/3. The chance for 2 to appear is 1/2. So the joint probability for 1 to appear and 2 to appear simultaneously will be 1/6. That's right. So what's the second one? 110 is the same. Pretty much they are all the same. If you times all of them, so it's all the same over here. So this is also 1/6. This is extreme case. Extreme case normally they differ. You can take a look. They all the same. 1/6. 1/6. 1/6. So now we can do the plotting of your x bar. This is a distribution. This distribution is like if only have 1 and 1, 2. So you are not going to write 1 and 2, but you are going to do the normal. This one is based on x1 plus x2 plus, divided by 2. So x1 plus x2 is divided by 2 is 2/3. So you can convert this one into another table because the some number are the same. You will see a some number. So it's better you plot a table over here. You plot a table over here. Okay. So in this table, this is your value, the value of your x bar, and this is your probability. This is your probability. I'll write down later probability. Okay. So if this number times plus this 1/3, 1/3, yeah, not 1, 3/3, 3 half, 3 halves, and then this number times plus this number is 11. So you have 11. Another value is 11 divided by 2, right? So this is the statistic over here. Statistic is we choose this it can be anything. You can choose this statistic to be divided by 3, divided by 4 or something. Divide by 2, I told you already, because in the end, if you are many bags, this number tends to be a normal distribution. It looks like this one. Normal tend to be a normal distribution. Anyway, so it's this one will be 11 over 2, and this one will be 7 over 2. 7 over 2. And this one will be 15 over 2. And this one will be 4. Right. And this one will be 8. 6 plus 10 divided by 2 will be 8. Okay. They are all different. If they are the same, you have to put the probability together, because they are all the same. So the probability will look like this one. 1 over 6, 1 over 6, 1 over 6. Okay. If they suppose this value they are the same, suppose that these two values are the same, then they put 1/3 plus 1 over 6 plus 1 over 6 is 1/3 together. So remember, it's just now is an extreme case. Okay, so in this case, you can easily plot this one. X bar will look like this one. Do the plotting. This one will be 1 over 6, 1 over 6, 1 over 6, 1 over 6, 1 over 6 over here. You just do the plotting of this bit. Okay, so now we get X bar over here. That's the meaning of X bar. So basically, it just means if a different kind of distribution over here, S1 distribution here, S2 distribution over here, and I average out X1 and X2, I get this one, the distribution over here, distribution over here. And that's pretty much the whole idea. So if you get a lot of this kind of number distribution, S1, S2 up to something, this distribution will look just like a normal distribution, just like this one. Just let you know. Okay, let's go back. So basically, now we have a normal distribution. This is your distribution. This is your expectation, your mean. This is your variance. All this, suppose it's a random number. You have this one. But now there is a problem. The problem is you don't know this one. You don't know this one. Most of the time. And even this one you don't know. So the reason you have to do all the we call the approximation, because if this one already know, you don't have to do anything. They are mean and variable also always there. So the best way is it based on your sample. You base on samples guess or the approximate. Theoretically, based on sample to approximate this one. This one is your most probable value. This one will become your standard error. Become your error bit. A standard error bit. So these two are the most important. So you have to estimate this one and this one. And this one is easy. This one is a mean. You just do all the mean is easier. This one is harder to estimate. But based on statistic, this one you can estimate this one by this number, by this one, and here you pretty much already kick in this one. Already kick in X bar, Y bar over here. Already have I use Y over there. It's Y bar. And you might wonder how come there is you only have a Y, only Y random variable over here. How come you because previously you say you have X1 up to Xn, and then but now it seems like you only have a Y is over here. How come you also need other random variable to do the guessing? You treat the one variable one variable the same. Treat they are the same. They are same. So I can do the 10 times the treat the S1 as X2 as X3 and so on and so forth. Why? Because you are, for example, like this one, this case, if you are doing the same machine, if you are using the same machine, it's basically you treat S1, S2, S3 are the same. Before you do the drawing. What does it mean? It means that the first time you draw, you already have a distribution over here. This one, the most probable value, probably A to B, probably, for example, the most probable is 19.2 meters. before you do the drawing, you're 90.2. So for first time, that's the true value. No one knows. For example, this is true value. Of course, it's based on the your sample to guess this one. And so you can assume the first time you draw, you already normal distribution over there. That will be x1 over here. So the first time you draw it, you might draw some value out of this one. So you start to the measurement. Measurement might lie this one. If you are lucky, very close to mean. If you are unlucky, it's pretty extreme. By the way, okay, good. And then you take a break after sometimes. You come back again, and then you measure again. You measure again. That become it seems you are facing a second one, random variable. So it's the same. You are facing the same one as well because the distance between A and B is always the same, pretty much the same. As long as your measurement time is very short, then you can treat they are identical. So x1 and x2 distribution will be the same. The second observation comes from this one as well, and third one as well. So in this case, we call it y. Not call it. Just like a distribution, like x1, x2, x3. They all treated as the same. So once you do the mean, this mean. This mean basically we'll get this one. If you do this mean. So pretty much based on the we call it the large number theory. So it's x1 as well. x1. In this case, x1 back x1, and then you do also you do the this one. And you will find out this value are very close to the mean value of this one. Very close to the mean value of this one. So if you get this one, give it this one. That's the reason you always do the measurement many times. Is because once the average out, you'll get the number. You get the number, the mean, very close to the center one. And based on the theory of statistics, based on the theory of statistics. Okay. If we keep on talking this, probably we have to just stop here. But again, I send you guys some data over here, so you probably won't understand straight away. But some of you probably already know what I mean. But some of you probably still no idea, but keep this one as a record. Sometimes we have to resort to this one again. And we take let's say 4 minutes break, and then when we come back, we'll start to look at the example again. Otherwise, we have no progress today. We just mentioned last time because some of you can't do your homework, so it's a serious problem. Today we'll look at the weight. Again, because this is the most important one. Wait again, and we'll use some other things. Again, hopefully, we can finish this bit. And again, we also have to. But if you really don't grasp or understand everything, the best approach I can recommend is because sometimes I need some statistics. So if you say I really can't comprehend this bit, so the best way you can do is you just follow suit. What do I mean follow suit? You just follow exactly the example of the textbook. What does the textbook write? You just change the number and follow suit and see how to do the calculation. Okay, so let's see, I'll look at one example, and for today's example, and I will explain this example, and then we pretty much will hopefully we can finish this bit today. We don't want to spend too much time on this one. They are important, that's for sure, but you can't just spend so much time on chapter 1. We have to keep going. Okay, 4 minutes break. After we come back, we'll look at example 1.2. I will try to look at example 1.2. Okay, 4 minutes break.